Good morning, students. So today we discuss the last few questions from the exercise 6.3 chapter lines and angles. So here already we complete 4 questions. So now you see the next question number 5. So here in this question already given here you see PQ and ST, these two are parallel, and now here this PS is the perpendicular on these two parallel lines. With respect to this, some angles are also given here, like SQR, this angle is given to you, as well as QRT, this angle is also given to you. Now our task is what we have to find out. We have to find out the value of this X and Y. Since it is perpendicular, that means this angle is already we know 90 degree. So now here to find out these two angles, first of all let's take this diagram QST with QR. Now separately this diagram we drawn here, you see QSRT, this diagram we have taken here. So now here in this case, if you see this angle, the outside angle, which one is known as exterior, and these two angles are the interior angles of this opposite side of this exterior angle. So there is a property, and the property is like that: exterior angle is equal with sum of two opposite interior angles, isn't it? So that's why we write here exterior angle QRT equal to interior angle here SQR plus QSR, here we write, you see. So exterior angle equal to sum of two opposite interior angles. So if we put the value and then if we calculate, then from here we get the result QSR. So this QSR we get here. Is it clear? So now after that, the next part, in two ways you can solve this question. So first one is, if you see here PQ parallel to ST, so easily we can say this QS is what? Transversal. If QS is transversal here, these two angles are what? Alternate interior angles. And if two lines are parallel, then alternate interior angles are what? Equal. So that means these two angles are equal. So this angle already we prove QSR equal to how much? 37 degree. So that means from here also we can say X equal to 37 degree. And after that, this is 90, this is 37 degree. If we get the sum of this triangle is how much? 180. And then from here you can find out the value of Y. So in this way also you can find out. So here another way we have done here. You see here PQ parallel to ST and PS is what? Perpendicular. Perpendicular means if this angle is 90, that means this whole angle is also 90 degree, isn't it? So that's why we write here PSR equals to 90 degree. So this PSR we can separate into two ways: PSQ, QSR, the sum of these two angles. So that's why we write Y plus 37 degree. Y plus this part is already we know how much? 37. So Y plus 37 degree. So if Y plus 37 degree, if you calculate, then we get a result here Y equal to how much? 53 degree. After that, if you see this triangle PSQ separately here drawn, so if you see here PSQ, so this PSQ is here, the sum of this triangle is how much? 180 degree. So this angle is 90, X and Y we put, and then it is 180. And if you calculate this one, from here you can find out the value of X from here. Is it clear? Okay. Now after question number 5, next question number 6. So in question number 6, the diagram given to you like in this way, and now here what we need to prove, this QTR, that means this angle is equal to half of QPR, that means this angle we need to prove. So in this question, first of all, Here PQR is an angle and here QT is bisector given to you. First of all, what? Bisector. PQR, in angle PQR, this QT is bisector. So bisector means, already we know, bisector means what? We can separate the angles in equal parts. That means these two angles are here equal. So that means this one is bisector. That's why. So now here similarly, if you consider another angle PRS, here again another bisector is given RT. So that means these two angles are what here? Equal. So these two bisectors when we draw meet at one place, and which one is mentioned as a T here. So that's why here written these two are what? Bisectors. So now here if QT and RT are bisector, that means from here easily you can say PQT is equal to TQR. This one. Similarly PRT, this angle equal to TRS. So that's why we write this. Now after that, now if you see here, if we draw separately this diagram, because we need QPR, so that's why if you draw PQRS, only if we draw this part, no need to draw these two bisectors separately. So the diagram look like is in this way. So in this case, if you see, this angle is what? The exterior angle. If this one is the exterior angle, these two are what? Opposite interior angles. So there is a property we know. Exterior angle equal to sum of two opposite interior angles. So that's why we write here PRS, exterior angle equal to sum of two opposite interior angles. One is QPR, another one is PQR. We write these two. Is it clear? So from here, this PQR we have to shift on the left hand side. So that's why we get minus PQR equal to QPR. So we keep QPR here because we need this result. Because in this proof you see QTR equal to QPR we need to prove. So now in place of this PRS we can write 2 times of TRS. Now the question is come here, how? So for that reason here we write this red part, you see here, this red part written here. So in exam no need to write this red part. This red part if you want then you can write inside. Is it clear? So in this case you see PRS equal to PRT plus TRS. How? PRS, the whole angle. So this whole angle we can write PRT plus TRS we can write. So that's why we write this two. Since we know these two angles are what? Equal. So that means in place of PRT, that means PRT, that means this angle. In place of this angle we can write TRS also. So that's why in place of PRT we write here TRS, you see. And TRS is already there. So TRS plus TRS 2 times of TRS. Is it clear now? So that's why here in place of PRS we write 2 times of TRS. Is it clear? I think all of you understood this. Similarly in place of PQR, that means PQR, we can write 2 times of TQR. Is it clear? So you can write here 2 times of PQT also, as well as you can write 2 times of PRT also. But we need these two results. Why we need later on you know. So that's why we write 2 times of TRS and 2 times of TQR. Is it clear? And then we take 2 common here. And then we put this one is this result we put equation number 1. Is it clear? So in the next part what we have to do, first of all we consider this triangle. Now second time we have to consider this triangle now. Again we apply the same property. So we keep this one is equation number 1 here. Now the next one you see. Now the next one is TQRS. Now here again we apply the same property here. This one is what? Exterior angle. So this exterior angle is equal to sum of 2 opposite interior angles. So exterior angle TRS we write, and the opposite 2 interior angles are, one is we have to write QTR, this one, and another one we write here TQR, this one. So we just save this TQR on the left hand side. So in equation number 1, TRS minus TQR, we get 2 times of TRS minus TQR. So in place of TRS minus TQR, we have to put QTR. So that's why from 1 and 2, if you put in place of TRS minus TQR, then we get 2 times of QTR equal to QPR. Is it clear? And if you shift these two, then we get our required answer. Is it clear? Okay. Now after completing question number 6, we consider an example number 6, and this one given in your book in page number 103. Actually this question is very important examination point of view, so that's why we have drawn here, and we take this one. Now first of all, here what given? AB, CD and EF, these three are the lines, and the condition is what? AB is parallel to CD given and CD is parallel to EF given. So one property we know, if AB is parallel to CD and CD is parallel to EF, so from here easily we can say AB is parallel to EF. Which one is we write here? Is it clear? This one is written here, you see AB is parallel to EF. Now here one more condition is given, EA, that means this line is perpendicular. If this line is perpendicular, if this AB, CD, EF are parallel, perpendicular means 90 degree. If it is 90 degree, since these two lines are parallel, that means this whole angle is also 90 degree. So that means what we can say here, EAB is 90 degree given to us, and here similarly we can write here AEF. AEF is also 90 degree. So AEF, that means the sum of these two angles, so that's why we can write Z plus 55. So Z plus 55 equal to 90, and from here we calculate Z result, we get here 35 degree. Okay, now after that, if you see, since AB and EF are what? Parallel. If AB and EF are parallel, we can easily say EB is what? Transversal. Is not it? If AB is transversal, then if we consider the angles on the same side, intra-angles on the same side, the sum of the intra-angles on the same side equal to how much? We know 180 degree. So that's why here written, you see intra-angles on the same side. So here intra-angles on the same side, here you see. So this one is written here, intra-angles on the same side, and the sum is what? 180 degree. So y plus 55 degree, so that means we write 180 degree, and if you calculate from here, then y value equal to, we get how much? 125 degree. So y value we get here, z we get. Now finally we have to find out x. So how can you find out x? Now let's see here, since AB is parallel to CD, if AB is parallel to CD, and if we consider DB is the transversal, what we can say about these two angles? These two angles are the corresponding angles. That means corresponding angles are always equal if the lines are parallel. So that means this y is equal with x. If y is equal with x, what is the value of y we get here? 125 degree. So that means if y is equal with x, then the x value is also, we get 125 degree. And which one is given here? You see this one, corresponding angle. Simply we write here corresponding angles. Is it clear? So this one is very easy and a common question. From examination point of view, you have to do this one also. So now your task is what? So here 6.1, 6.2 and 6.3, all questions are actually not done. Few questions are already done here. So your task is, you have to complete each and every question, including the example questions also. Is it clear? And one more thing here, one theorem, which one is the sum of three angles of a triangle is 180 degree. This one is another very important theorem, and example questions are you have to do. And if you complete all the questions, then this chapter is complete. So that means this lines and angle chapter is complete. Is it clear? And in our next class, we have to start another new chapter. Let me see which one we have to start. So First of all, you have to complete this all questions and the example questions. Is it clear? Okay, thank you.